Okay, we're practicing rational root. It's the hardest part of what you need to know for the test. The test is coming up on Thursday. And so we have one more day to review tomorrow and then the test. So today can be kind of a shorter, fun day. Got a little movie clip I'm going to show you that's kind of fun. And anyway, this is one big honking blue problem here. This guy can be solved by using FCon over FCO, factors of the constant over factors of the coefficient. You take all of these and you divide it by this. Well, you divide by 1, you get the same answer as you had before. So basically, these are all the things you'd have to test. Isn't that insane? But the reality is you only have to test until you find something that works. And there are several things that work. There's like 4 things that work in this one. So if you're pretty likely after you test 2 or 3 things to find it. All right. So I'd like you to use synthetic, which of course is this method where you like test 1 and you go 1, 4, negative 12, negative 64, negative 64, etc. And then you drop down and see whether it works. Okay, I want you to use synthetic. I'm going to tell you which ones I want your row to test. I don't want you to be, you already got one? All right, I figured. But everybody else, I want you to try the ones I tell you so that we'll find, I'm going to show you something kind of cool. If we find enough of them that work, we can go directly to the answer, and it saves a lot of time. All right, you guys, I need you to test 1 and negative 1. You guys, 2 and negative 2. 4 and negative 4 for this row. 8 and negative 8. 16 and negative 16. 32 and negative 32. Okay, now, I need you to test the ones I gave you because it's a little different than what we used to do. If you just find one that works, that does work. But it's kind of cool if you find like 4 things that work, you can jump right to the final answer. I'll show you what I mean in a second once we find one that works. Or 2 or 3 or 4 things that work. Verified 1 does not, 1 and negative 1 does not work?
1 does not work.
1 does not. Okay, try negative 1. How about this? Have you found anything that you think does work? 4 and negative 4 appear to work? That would be 2 things. So you guys did 1s, 2s, 4s. Could you verify that 4 or negative 4 worked? Okay. All right. And there's probably more. Negative 2 works? Can anybody else verify that? He was the first, so let's double check. Check negative 2 and see if your negative 2 really works. Somebody who's fast. You know, some of you guys are really fast at this. I'm fairly fast at it because I've been doing this a while, but it is true. It's much harder if the numbers are big. Yeah, 32 is pretty brutal. Oh, a couple people say negative 2 works. All right, I'm believing you. Yes? All right. What does this mean? This means that in the final answer that you're probably going to have an x plus 4, an x minus 4, and an x minus, oh wait, I got to do, if it's negative 2 that works, x plus 2 is probably in your final answer. Do you get what I'm saying? And if I do that, though, I'm only going to have 3 of my roots. Blast it. Because if I had the 4th one, then I'd know I was done. You get how this is degree 1, degree 1, degree 1. That makes a total of degree 3, and I'm supposed to have 4 roots. And therefore, if we could just find one more thing, we'd be done with the whole thing. But sometimes you can't. And it does take a while to do it this way. So I'm going to go back to the normal way. The normal way is, once you've found a root that works, what I'd say negative 2 probably is one of the easier ones to test. So I'm going to show you a reminder, especially for those of you at home who are still learning how to do this. If I add a page here, I take this onto my new page, and I'm testing negative 2. It goes like this. 1, 4, negative 12, negative 64, negative 64. Draw the line. Drop it like it's hot. negative 2, 2, negative 4, negative 16, positive 32, negative 32, and then positive 64, and yes, it worked. Nice job. So then, what's my answer? I bring this down and make it a parenthesis and say x plus 2. Then I make this whole thing a parenthesis. And the last one's just a constant. This is x's, this is x squareds, and this is x cubed. I have to put in a little plus in the gap there because you can't just have two numbers sitting by each other. Raise your hand if you had that. Okay, now if you believe then that 4 also worked, then you can figure that 4 is going to go into this one now. So now, you do the same thing. You take this part here, you do synthetic with a 4. And you go 1, 2, negative 16, negative 32. Draw the line. Drop it. 4, 6, 24. Negative 16 and positive 24 makes positive 8. 8 times 4 is positive 32. Makes a 0. Yes. Now here's the mistake people make. They get to this part, they go x minus 4, even if they're smart enough to know that, and then they say that this is x and this is x squared, put a plus, put a plus. They forget something. What did I just forget? And I get the whole problem wrong. Bring that down. All right, and now there were rumors that x plus 4 also worked, or that positive 4 or negative 4 both worked. Then I can just drop this down, take this and factor it into two things, one of which is probably x plus 4. Get what I'm saying? And then I can figure out that times what, x plus, and I got to figure out what, must be a 2, because 4 times the 2 has to make 8, right? So that must be a 2, and there we go. I got my answer. X plus 2, x plus 2, x minus 4, x plus 4. And that's why we couldn't figure out why there was an extra root missing, because there were 2 of these. You get what I'm saying? You couldn't have known which one was the double root. So that makes it tricky to do by trying to find all the roots ahead of time and make the answer all at once. If the roots happen to all be different, like one's 4, one's 6, one's negative 2, and one's 13, then you can do it that way. Yes? Yes, you can do that, but you don't have to. Yes?
On the test, how will you be able to know if there's going to be multiple ones that work?
I will tell you right now that the test usually, I know I couldn't say that, always on the big problems will be able to be factored at least twice. Only on the big ones. Okay? And the smaller ones, usually you just factor it once and you're done. All you really need to ask yourself is this. Once I've factored it, you have to test and see, can this be factored again? Now, there's another way we could have factored that. Divide and conquer. It probably would have taken less time. But synthetic's pretty fast too, so. That's true. Synthetic does take up a lot of room. All right, we're going to talk over, this is just the solution to the one we just did. Here is the divide and conquer part of it. If you had just had to do divide and conquer right here, try this one with divide and conquer, or with factor by grouping is another way just to call it. There are problems on the test where the only way you're going to be able to do it is divide and conquer. Now, I can't say that because you could use synthetic on this kind if you knew which ones to test. So use the rational root to figure out what to test, etc. All right, I do need you to try this right now on your paper, unless you're already done. Try factor by grouping. If you don't know how to do this, you're missing a major tool. Sort of like a carpenter who goes out to the job site and doesn't have a saw. He's got 10 drills and a couple of hammers, but no saw. In certain problems, this is the tool to use. All right, so x squared goes into both parts, and I get x plus 2. And then right away I know that this puppy probably has an x plus 2 in it, right? All right, I'm not positive of that, but I can assume it probably does. And then I figure out, well, what could I take out to make that work? Negative 16 would make that work. Okay, now this is in common, and so the x plus 2 comes to the front. And then I have x squared minus 16. And I recognize that one. That's where we got the plus 4 and the minus 4 from, right? So this part would be x plus 2, and then x minus 4, and then x plus 4. And then there's one that's missing because we started with this original problem. And the very first problem I gave you had that other factor of x minus 2 in it. No, another x plus 2 in it. That's why it had a final answer like this. But given what I gave you right here, it should have 3 answers. And it does. Yes?
So if you factor all the way,
Mhm.
you don't have to get the factors of the other two that way?
If you factor it all the way, then your solutions to these are easier to see. X equals negative 2, x equals 4, x equals negative 4. Is that what you're talking about, those solutions?
Yeah, and let's say like 4 also works into synthetic, and then do we have to factor that all the way, or just give us like
If you, no matter which method you choose, you need to factor it all the way. So when you're done, when you think you're done, you should look at each part and say, can I factor that any farther? Can I factor that any farther? Can I factor that any farther? And if you can't, then you're done. I don't know if that answers your question or not. If not, explain it to me again later. All right, move on. Our fully factored answer was this. So these are all real roots. Do you get how none of them are imaginary? If I had had a squared right there, do you get how this part would then have an imaginary root? If it did, then I'd say this. X squared plus 2 has to equal 0. Solve it. X squared equals negative 2. Square root of that, square root of that. X equals plus or minus I root 2. Do you get how that worked? You have to do that in the test. There's like 3 or 4 of those. So if you're not good at that, you need to talk to me about that. All right. Here are the topics. For those of you that are the organized sorts that like to write down, you know, what am I supposed to know for this quiz? You do not have to write these down. You can if you want to. Factoring this kind, it's plain old-fashioned, make 2 sets of parentheses. You got to be able to do that. This kind is called a difference of squares because that's a perfect square and that's a perfect square. You should be able to slap that in right away and say it's x plus 6, x minus 6. Do you get that kind? Okay. Next kind. This kind is harder than just x and an x to start with. It's not that much harder, but it's 5x and x is what you start with. And then you guess and check with this number and this number until you get a middle term that works. Okay? And the 2 question marks have to multiply and make that. You remember that kind? Okay, next kind. Factor by grouping. We just talked about that a second ago. This kind is the divide and conquer kind. This kind can just break into 2 parentheses, x squared is how you start. Does it all ring a bell? You feel comfortable with all those kinds? All right. And there's more. Long division we are not doing on the test. Synthetic division, we just did one of those. Is this a solution to that? Well, you stick that in the little negative 2 in the little thingy, and you go away with your synthetic process, and you see if it worked or not. All right, rational root lists possible factors of. That's factors of the constant over factors of the coefficient. F-con over F-co. Now that tells you what could be the roots, and then you test them with synthetic, and then you can find really hard ones using this. There will be 2 at least on the test that are really tough, like the really long ones, and you got to factor it and then factor it again, and then maybe even factor it a 3rd time to finally get the answer. All right, your homework for today is like that. It's big ones. There's only 3 of them. They're on a yellow sheet. That's what I'm assigning for today, and then we're going to do something fun in a minute.